All right, guys, welcome to Unit 11, Day 1. This is for acids and bases. Today we're going to find out how to recognize, name, and write the formulas for common acids and bases. Okay, so how are H plus and OH related in a solution? Okay, so the self-ionization of water, this reaction can be written as a simple dissociation. Okay, so dissociation is separating from the compound into its separate components. So it's separated into a positive hydrogen cation and a negative hydroxide anion, polyatomic ion. Okay, H2O ionizes like this only to a very small extent. In an aqueous solution, hydrogen ions are always joined to water molecules as hydronium ions. Okay, so H2O plus H plus creates H3O plus. Okay, because they join with the water, chemists may refer to hydrogen ions as hydronium ions or even protons. Okay, in this class, either H plus or H3O plus can be used to represent hydrogen ions in aqueous solution. Okay, so you need to remember, if you see H plus or H3O plus, it's essentially the same thing. If you want, highlight that, circle it, whatever you need to do. This is very important. Don't forget it. Okay, an acid is commonly defined as a compound that produces hydrogen ions when dissolved in water. So, let me find my pencil. There it is. So, acids create hydrogen or the H3O plus. Okay, either one of those. Okay, and a base is generally a compound that produces hydroxide ions. OH negative when dissolved in water. Okay, hydroxide, your hydroxide ion is also a polyatomic ion. Okay, it's one of those ones we had to learn whenever we were learning last semester, I think. Okay, so our Arrhenius definition says that acids are a substance that contains H or hydrogen and dissociates in water to produce H plus or H3O plus. And your base is a substance that contains an OH and dissociates in water to produce that OH. Okay, so we'll be able to recognize this, an acid, anytime you see an H. Ooh, Kim, that was not a good color to pick. I'll just circle it. Anytime you see an H, that's going to be our acids. So it will produce that H3O plus. And your base, anytime you see that OH, that's going to produce an OH in the end. So this is always known as a base. Okay, so you'll be able to recognize your acids by the fact that your formula will start with a hydrogen. Okay, so here we have HCl, HNO, H2, HClO3, H3. Those are all going to be examples of acids. So as you become more sophisticated in chemistry, you'll realize that many acid formulas do not start with H, but for our class, we're going to only consider the ones with the H. We like that. Okay, and recognizing bases, at this very beginning level, you'll recognize a base by the fact that its formula begins with a metal and ends with a hydroxide ion. Okay, so here we have potassium, that's a metal. Here's our hydroxide. Calcium is a metal. Our hydroxide. Nickel is a metal. Hydroxide. Aluminum is a metal. And our hydroxide. So later we'll learn that there are other examples of bases, but for our class, we only care about the ones that end in OH. Super nice. Okay, so look at these bases once again. These should all look very familiar. Okay, that's because we have our metals, our cations, our metals on this side. And then on the other side, we have our hydroxide anion, which is a nonmetal, or polyatomic ion. Okay, so we've already done this before. We did this last semester. We learned how to create ionic compound names with our metals and nonmetals. Okay, so we name and write our formulas of bases the exact same way we learned how to do with ionic compounds in, I think, Unit 4. It's either Unit 3 or Unit 4. Okay, so we have two classes of acids that you need to know. We have binary acids, which have only 2 elements. Okay, bi means 2, so we only have 2 elements. So we'll have hydrogen plus 1 other element. So for example, HCl. Okay, and then we have oxyacids, which contain 3 or more elements. So if you remember that bi means 2, then you'll always remember that the oxy is just the rest, 3 or more. So we'll have hydrogen and oxygen and at least 1 other element. So this is usually the ones that have polyatomic ions in it. All right, so naming our binary acids, this formula will only have 2 elements, and it will begin with the word hydro. Then we'll write the name of the second element with a suffix ic, and then add acid to the end. Okay, so for example, we have H2Se. See how we start with an H? That's an acid, not a base. Okay, so we'll start with hydro. And then Se is selenium. Okay, but we're going to get rid of the IUM and change, of the UM and change it to selenic, and then acid. Okay, next we have H here, so this is an acid, again, and then Cl is chlorine, so we have hydro, and then we have chlorine. We're going to get rid of the Ne, change it to ic, so we're just going to add the C, so chloric acid. All right, pretty easy. So hydroselenic acid and then hydrochloric acid. So let's do some practice. So all 3 of these, we have H as our first thing, so we know that these are all acids. All right, so we can put hydro at the beginning of each one of these. All right, and then looking at Br. Br is bromine. But I'm going to get rid of the Ne, change it to C. So hydrobromic, and then add acid at the end. Not add, acid. All right, next one is F. F is fluorine. Take out the Ne, turn it into a C. So hydrofluoric acid. All right, and then N is nitrogen. Take out the OGEN. It's going to be nitric. I don't know why I put 2 C's. Thick with a double C. Anyway, nitric acid. You can tell I've been sitting here for too long. All right. So we have hydrobromic, hydrofluoric, and then hydronitric acid. All right, my only 2 exceptions, and I want you to highlight these in your notes, are phosphorus and sulfur. Okay, phosphorus is spelled phosphoric, and sulfur is spelled sulfuric, not sulfic and not phosphoric. Those sound weird. All right, so let's do these 2 examples. I've got H as both of these, so they both start with hydro. P is phosphoric, and then acid. And then S is sulfuric, and then acid. So we've got hydrophosphoric and then hydrosulfuric. All right, next are our oxyacids. Okay, these have at least 3 elements. So we'll start with writing the name of our polyatomic ion. So you have to be able to recognize where which one is a polyatomic ion. Okay, and then if the ending of my polyatomic ion is 8, we got to change it to ic, and then add acid at the end. So the best way to remember this is, ooh, I ate too much and I feel icky now. So 8 changes to ic. So let's do a couple of examples. So I have H, so there's my hydrogen, and then C2H3O2. That's going to be my polyatomic ion. Okay, this is acetate. Okay, you see the ATE? That ATE we're going to change to ic. So not hydro. Let me erase that. Okay, back to my pen. Okay, so this is going to be acetic acid. No hydro because we have more than one, so we can't name that singular element. We have to name the whole compound. Okay, next one we have hydrogen with CO3. If you look at your polyatomic ion list, you'll see that that is carbonate. I believe I'm looking at my paper. Yeah, carbonate. So we gotta change that ATE to IC. So we have carbonic acid. All right, so acetate turns into acetic acid, carbonate turns into carbonic acid. All right, if our ending is ITE, we need to change it to OUS and then add acid at the end. So best way to remember this is bites are delicious. So ITE change into the OUS. All right, so let's do a couple of examples. Again, here's my hydrogen. That's how I recognize that those are acids. And then ClO2 is, what? How come I didn't write this? Oh, chlorite, sorry. Chlor-ITE. We see the ITE, we change it to OUS. So this acid. And then NO2 is nitrite. So that's going to be nitrous acid. Okay, if you don't have your polyatomic ion list, you need to go and grab that. It's going to be super helpful. All right, so let's do some practice. The best thing I want, or the fastest thing I want you to do is either name if it's binary or oxy. So I'm going to go through this list. If we see two elements, so just two, that's binary. 3+ is oxy acid. Okay, so first one, HF, that's 2, so that's binary. Here we have H with chromate, that's going to be oxy. Here's H with P and O, oxy. H with Se, binary. H with SO, that's going to be oxy. And then H and I is binary. All right, let's do our oxy acid ones first. I think those ones are easier because all you got to do is list your polyatomic ion. So let's do this one first. So we have CrO7, so that's chromate. Okay, see how we have ATE at the end? Remember my saying is I ate too much, now I feel icky. So I got to change ATE to IC. So chromic acid is this one. All right, the next one is PO3. All right, PO3 is phosphite. ITE. Okay, if we see ITE, we have to change it to OUS. My little saying is that bite is delicious. So ITE, that bite is delish, OUS, delicious. Okay, so this is going to be I don't know how to spell apparently. Phosphorus acid. All right, next one that we said was oxy, SO3 down here. So SO3 is going to be sulfite. Got to change that ITE to OUS. Remember that bite is delicious. So sulfurous acid is that one. All right, let's move on to the binary ones. Okay, so these ones all have H as my starting. So we're going to put hydro first for all three. Okay, and then F is fluorite, so it's going to be fluoric. Se is selenium, so that's selenic. And then I is iodine, so that's going to be iodinic. And then acid goes at the end. All right. So now let's write some formulas. All right. So formulas for acids. So our binary acids, if it has the name, if it has acid at the end, and it begins with hydro. Hydro is the main thing that you want to look for. It is going to be binary. Okay, so first thing I want to do is write my two elements. So hydro means that there's always an H plus. So my first element is always H plus, and nitric is going to be just an element. Okay, this is not a polyatomic ion because it's binary. That means there's only two elements. So if you ever have more than two, then it's not binary. That's going to be your oxyacid. Okay, so nitric is just nitrogen. And then looking at your periodic table, it's in group 15. So if it's in group 15, it has an oxidation number of +3. Okay, sorry, not +3, -3. Oopsies, -3. Okay, so N -3. Okay. Oh, I stepped forward a little bit. So my two elements are H and N, and then you move forward like you would with ionic compounds. Okay, so we wrote our symbols first, right? Our charges or our oxidation number. So charge or oxidation number, we get this from our group number. Group is the columns that go up and down. All right, and then we crisscross these, so the H plus 1, N minus 3. That 3 comes way down here. Not the charge, just the number. That 1 comes over here. And then we have H3N1. So we'll reduce and erase, and it'll just be H3N. All right, so let's do an example. So step 1, I have hydrochloric acid, so I'm going to write H plus for my hydro. Chloric is Cl. Step 2, I'm going to write my charges. I've got my plus for hydrogen already. Chlorine is in group 17, so it has a charge of -1. So that 1 comes down here, that's my step 3. My plus 1 comes down here, so I have H1Cl1, then I reduce and erase, which leaves me with just HCl, hydrochloric acid. All right, for oxyacids, if my name has acid in it and it does not begin with hydro, we can conclude that it is an oxyacid. Oxyacid acid. So it'll begin with H, but then it will be followed by a polyatomic ion. Okay, so for example, we have perchloric acid. Okay, so the two parts of it, H plus is always the first one. Second one, we want to figure out which polyatomic ion this is. So if we get rid of the IC and just look at your list, our list, perchlorate is the only one that matches that. So perchlorate is this polyatomic ion, and its formula is PO4 -3 with a charge of -3. Okay, so perchloric acid, we have H and ClO4. Okay, remember our little saying is I ate too much and I feel icky now, which is why I got the IC at the end. All right, so that leaves me with HClO4. Oh, I was looking at the wrong one. Yikes. Okay, going back up here. It's not PO4. I messed that up. My bad, guys. It's not PO4. It's ClO4 with a charge of -1. I was looking at the wrong one. My bad. All right, so ClO4 is my actual polyatomic ion. We put our charges H plus 1, ClO4 minus 1, crisscross them. So that's H1, ClO4, 1, reduce and erase, and that leaves me with HClO4. I'm so sorry about that. All right, so let's do another example. We have phosphorus acid. All right, OUS, remember our bite is delicious. So if we changed it to OUS, that means it had ITE. So this is phosphite. All right, so my acid is always H plus. Phosphite is PO3, capital O, 3, with a charge of -3. All right, then I crisscross. My plus 1 comes down here. My -3 comes down here. So it's H3, PO3, 1, and then I reduce and erase, That leaves me with H3PO3. Right? So let's do our examples. So if we see hydro in there, that's going to be binary. Okay, so binary has hydro. And oxyacids will not have hydro. So I'm going to write hydro, take my red color, mark it out. No hydro. Okay, so my binary one has hydrofluoric. So we know that in binary there is no polyatomic ions. Okay, and this one, yes, polyatomic ions. I just abbreviated polyatomic to PA. Okay, so binary, we've got hydrofluoric. So my first one is H plus always. And then fluoric, that IC, remember, I ate too much and now I feel sick or icky. So ATE is what this used to be. Oh, you know what? I'm done. Not ATE. Okay, so this is actually fluoride. And fluoride is in group 17, so it has a charge of -1. Crisscross my ones, 1 and 1, reduce and erase, so that's HF, hydrofluoric acid. All right, let's look at this bottom one too, because it's also binary. So I have hydro, which means that it's binary. I have H plus, and sulfuric is just sulfur. So S, sulfur is in group 16, that's -2. Crisscross, that 1 comes down here, that 2 comes down here, so this is H2S. All right, and then sulfurous acid, that OUS, let's see, that bite is delicious. So that OUS was ITE. So this is sulfite. Okay, so sulfite is SO3, -2. But first I'm going to write out my acid. So my acid is H plus, and then my sulfite is SO3 with a charge of -2. Crisscross, so I bring that 2 down here. This 1 comes down here. There's going to be H2SO3. All right, my last part. We're going to decide if each one of these, we're going to fill out their names, decide if they're an acid, base, or salt, fill in their cation, anion, and then write their formula. This sounds super fun. Okay, so the first thing I actually want to do is if I see a hydro in there, I'm going to go ahead and say that that is an acid. Okay, and my acid always produces a positive H plus and then something else. All right, sodium sulfide. Okay, if I have that IDE, doesn't start with hydrogen, this is just going to be a regular ionic salt. So your ionic bonds are also salt. This is regular salt. So actually, I can go ahead and do my anion and cation. This is easy. So my cation is that sodium, Na. Sodium has a charge of +1 because it's in group 1. And then sulfide, because it has that IDE, that means it's just the element. Okay, if it has an ATE or an ITE, that means that it's a polyatomic ion. Okay, so that means that it's S. Sulfur has a charge of -2. Then I crisscross those. That 2 comes down here, that 1 comes down here. So this is going to be Na2S. All right, next one, we have BeOH. You see that OH there? That means that I produce a hydroxide. So this is going to be a base. Okay, let's go ahead and crisscross these. That 1 comes down here. That 2 comes down here. So it's going to be BeOH. 2. Okay, so whenever we're naming our bases, go back to your notes. Or not, actually we don't need to learn our base naming yet because it's really easy. It's like naming your regular ionic compounds. So we put our first one, that's beryllium. name our polyatomic ion, which is hydroxide. That's it. All right, sulfurous acid. Okay, this one doesn't have hydrogen in it, or hydro in it. So if we don't see hydro, then this is going to be a polyatomic ion, so Pa. All right, and we have that H plus 1 that's always there. Sulfurous, that OUS, that bite is delicious. This used to be ITE. So that's going to be sulfite. Oops. Oh, what happened? My pen just decided to wig out on me. Okay. So sulfurous, that OUS used to be ITE. Remember that bite is delicious. So sulfite is SO3, -2. Oh, why did I write that there? Sulfite is SO3, -2. All right, then we crisscross those. That gives me H2SO3. Okay, this one we have H plus and SO4. Okay, if we produce that H, that means that it's going to be an acid. ACID. Apparently I don't know how to spell. Okay, so because we have a polyatomic ion, I don't write hydro. So we're going to write this SO4 too is sulfate. Remember, ATE. I ate too much and now I feel icky, so ATE goes to IC. So this is sulfuric acid. Okay, then we crisscross our things, so it's going to be H2SO4. All right, ammonium hydroxide. Ammonium is actually one of your positive polyatomic ions. So this is NH4. Hydroxide is OH negative, and because of that OH negative, it's going to be a base. Okay, then we crisscross our charges. That one comes down here. This one comes down here. So it's going to be NH4OH. All right, and then strontium chloride. I don't see hydro in there. I don't see hydroxide. So this is actually just going to be a salt. Okay, so strontium is Sr. Chloride is Cl. That IDE means it's just the element. Okay, strontium has a charge of positive 2. Chloride has a charge of -1. I'm going to bring that 2 down here, that 1 down here. This is SrCl2. All right, and then we come back up here. I can finish this first one out. So hydrosulfuric acid, since this is binary, that means that there's just 2 elements. So this is not going to be a polyatomic ion. It's just going to be sulfur. Okay, and sulfur has a charge of -2. I'm going to bring that 2 down here. Bring this 1 from my hydrogen down here. So it's going to be H2S. All right, if you're having any trouble with this, please don't hesitate to come into tutoring and we will be more than happy to help you out. All right, have a good one.